Okay, let's go through some examples where we are going to identify a quadrilateral, and we'll use our chart or Venn diagram to really figure out what's the most specific name. So directions, give the most specific name for the quadrilateral. Okay, so looking at this first one, I see I have a quadrilateral. And I see I have these markings. And remember, these markings mean that those are congruent. So I see that AE is congruent to EC and ED is congruent to EB. So I see that the diagonals are bisecting each other. So I'm going to go to my chart and look to see which ones have diagonals bisect each other. And I see that is under parallelogram. Parallelogram, the diagonals bisect each other. So I know that this is at least a parallelogram. But I know that parallelogram breaks off into more shapes. So let's see if it has the properties below it. So let's see, is it a rectangle? Does it have 4 right angles, or are the diagonals congruent? Well, looking here, my diagonals aren't congruent. They would all need to have the same tick mark here. This BE is different than EC because it has the different tick marks. So it's not a rectangle. I also don't know if this has 4 right angles. I know it looks like it in the picture, but it's not marked. It needs to have a marking of a right angle, so I can't assume. So it's not a rectangle, which automatically means it's not a square. For a rhombus, it would need 4 congruent sides, diagonals are perpendicular, diagonals bisect opposite angles. Here, I know it looks like it has 4 congruent sides, but it's not marked, so I can't assume. I also don't have a marking that the diagonals are perpendicular to each other, so I can't say it's a rhombus. So that means the most specific name for this one is a parallelogram. Okay, let's look at the next one. So here I see I have a quadrilateral and I have these side lengths. So I see that RS and ST are both 50. So since they are the same length, that means they're congruent. RU and UT are both 51. So since they have the same length, those two are congruent. So here I see that I have 2 pairs of congruent consecutive sides. So I need to look and see which shape had that. Well, rhombus, that was 4 congruent sides. Trapezoid, no. Okay, I see that for the kite. The kite has 2 pairs of consecutive congruent sides. So that means that for number 2, the answer here is a kite. Okay, let's look at number 3. So number 3, I see I have a marking for VW and YX being parallel. I can see that VY and WX clearly aren't parallel. It's also not marked to be. So I see I have 1 pair of parallel sides. For this example, I'll go ahead and use this chart so we can look at it for a different way. So I'm looking for the 1 pair of opposite sides are parallel, and I see that's here. So the only 2 shapes that have that property are my trapezoid and isosceles trapezoid. So I need to figure out which one it is. So I know it's at least a trapezoid. Isosceles trapezoid has a few more things that come with it. I see for an isosceles, it has exactly 1 pair of congruent sides, and the diagonals are congruent. I don't know anything about the side lengths, so I don't know whether it has a pair of congruent sides, but I do have information about its diagonals. So for it to be isosceles, it would need to have these diagonals be congruent. Well, when I do 75 plus 62, that comes out to be 137. When I do find Vx, 64 plus 80, that comes out to be 144. So those aren't equal to each other. Since they're not equal to each other, it's not an isosceles trapezoid. So this will just be a trapezoid. Okay, looking at this last one, I know one side is 9. I have one pair of congruent sides, and I know one diagonal is bisected. Okay, let's see. Opposite sides are congruent, just one pair. Those are consecutive. That one has both pairs. Nope. I don't know if both diagonals are bisected, so I can't say it's a parallelogram. So this one actually doesn't fall under any of those. Since it doesn't have the properties of any of them to label it, I would just call this a quadrilateral.